So in order to get really good and confident with these dot structures, you just got to practice. So let's go over a couple. The first practice one is F2. Okay, so F2, diatomic fluorine. So I draw my fluorine. It's got 7 valence electrons. 4, 5, 6, 7. And I draw another fluorine with 7 valence electrons. And so hopefully now you just visual spatially, you kind of get used to lining up the single dots. So I know that's where the bond is going to form. 7. I can connect the dots, and there's my F2, diatomic fluorine. And we mentioned that hydrogen and halogens are single bonds for life. I'm never going to think about like double bonding or triple bonding halogen. They've already got 7 valence electrons, and they just want 1 more. So why would they make a triple bond? That's like 3 more electrons. Same thing with hydrogen. Hydrogen only needs 2 electrons. It's filling the first energy level. It already has 1. Hydrogen and halogens are single bonds for life. What if I look then at O2, diatomic oxygen? Okay, so oxygen has 6 valence electrons, and they're organized as 2 pairs and 2 singles. That's kind of how they would be if I were drawing out like the orbital diagram. It would be like 2s2 and then 2p4. And so the 2 electrons in the 2s are paired, and then of the 4 electrons in the 2p orbitals, 2 of them are paired and 2 are single. So it kind of matches the dot structure. Now I want the single dots to line up because that's where the bond goes. So you kind of rig it so that I put the single dots so they match up with each other. Connect the dots once, and what do you know? We could connect the dots twice. O2, diatomic oxygen, is a double bond. Each oxygen has 6 valence electrons, wants 2 more. Yeah, we'll just double bond them, right? Perfect. Now with oxygen, or anything in the oxygen family, oxygen, sulfur, selenium, tellurium, they've got 6, they want 8, they can take 2 bonds. That's the first time that I start thinking about maybe a double bond. Do I think about a triple? Probably not. That's not going to be my first thought when I see something from the oxygen family with 6 valence electrons. I'm probably thinking either 2 single bonds or I'm thinking 1 double bond. When I get next door and I'm looking at maybe like N2, diatomic nitrogen. All right, well, I'm going to draw my dots so that the singles kind of pair up. And I know there's going to be 1 pair and 1, 2, 3 singles. Pair and 3 singles. Now, often I draw my pair on the top, but I know that I'm going to be bonding another nitrogen, and so I want those singles to kind of line up. That's where the bond goes. And so I'm going to purposely put the pair toward the outside. Oh, okay, I remember this guy. Each nitrogen wants 3 more bonds, so we can just bond them to each other 3 times. Perfect. The nitrogen family, nitrogen, phosphorus, arsenic, antimony. That's the first time when I really start thinking about triples as being a good option. They need 3 bonds, so they could triple bond to each other. Or I'm thinking some combination. It could be like a double bond and a single. That would get me to 3 bonds. Or maybe 3 single bonds. Cool. So the single bond, double bond, triple bond thing, to some extent, is a little bit predictable in that, yeah, I'm not going to triple bond a halogen, and I'm probably not very often going to think about triple bonding something in the oxygen family. But yeah, when I get to nitrogen, I'm thinking triple bond is possible. Or when I get to oxygen, yeah, the double bond is possible now. I mean, to some extent, I'm still kind of drawing the dots on paper to see where things line up. But I can at least somewhat predict if a double bond or a triple bond would even be a viable option. Okay, so now, for example, let's do some carbon structures. CH4. So easy, right? You got one carbon, goes in the middle with his 4 valence electrons. I have 4 hydrogen. Perfect. I can hook those 4 hydrogen on the outside, lining up the 4 single dots. Get out of there. And single. Perfect. Connect the dots. 1, 2, 3, 4. So the central carbon will make 4 single bonds. Carbon's got an octet. Hydrogen's got his duet. Everybody's got a full, stable outer shell. All right, so let's try a couple other options with carbon. I love drawing carbon structures. How about this guy? CH2O. All right, so I've got 1 carbon and 1 oxygen. Who's going down in the middle first? Well, it's going to be the atom that can make the most bonds. Carbon has 4 valence electrons, and so we can make 4 more bonds. Oxygen's got 6 valence electrons, and then he can only make 2 bonds. Carbon for the win. Carbon's going to make 4 bonds. 2, 3, 4. Now I just kind of start hooking things on. It doesn't matter where you put them. If you've got different atoms to hook around the outside, it doesn't really matter where you put them. At some point, I've got to hook on 2 hydrogen. Okay, so maybe I'll go 1 on the top with 1 valence electron. Maybe I'll put 1 over here with 1 valence electron. I know I can connect these dots right away because hydrogen's done. It can only make 1 bond. Now, do you see what's going to happen? I've got this oxygen. I don't know, I'll put them over here. The oxygen has 6 valence electrons. He's going to make 2 bonds. Well, it just so happens that there are still 2 more electrons on the carbon. So we're going to kind of rig it a bit. We're going to rig the dots. With my 6 valence electrons that I need to draw around the oxygen, I'm going to purposely line them up so that the singles on oxygen would match the singles on carbon. And then I'll put the pairs kind of toward the outside. So I can connect once, and I can connect twice. Look at that. So carbon needs 4 bonds. He can make 4 single bonds. He could do a double and 2 singles. Isn't that cool? Where your carbon in the middle's got 8. All 8 are bonding electrons. And the oxygen's got his 8. 2 pairs of bonding electrons and 2 pairs of non-bonding electrons. Sweet. They're kind of fun, aren't they? There's another one. Hcn Hydrogen Cyanide. This is in gas chambers. Okay, so we got 1 of everything. Who's going down first? Well, if there's ever a carbon, I guarantee he's going to be the winner. Carbon's going in the middle. He can make the most bonds. He can make 4 bonds. And that's the most that we're going to deal with. There are some elements that can make more than 4 bonds, but then that's called an extended octet, and that's for a second year course. So carbon's going to make the most bonds that we'll deal with, 4. Now you just start hooking everything together. I've got 1 hydrogen. He makes 1 bond with 1 valence electron. And so I know that's it for the hydrogen. Connect the dots, why not? And then I got a nitrogen to hook on. Okay, I suppose I'll give you a nitrogen. He's got 5 valence electrons. But now I kind of see where the bonds need to go. So I'm going to rig it a little bit. And I'm going to put the single dots on nitrogen so they match up with the single dots of carbon. And then that extra pair can go on the outside. I still have to show that nitrogen has 5 dots or 5 valence electrons, but I can be a little more creative in how I want to arrange those 3 singles in that one pair. It just depends on what I'm going to bond it with. But I always want the singles to line up. 1, 2, 3. Check it out. So carbon can do all kinds of things. He can do 4 singles. He can do 2 singles and a double. He can do a triple and a single. Whatever gets him that total of 4 electrons. So with carbon, anything's possible. Same kind of thing with nitrogen, I guess. Making 3 bonds, I'm thinking maybe 1 triple. It could be a double and a single. Or maybe it could be 3 singles. Cool. Okay, so here's the only other ones that we want to look at. Something where maybe you don't have one central atom. So for example, N2H2. What if I wanted to draw N2H2? Oh boy. Well, you got 2 nitrogens, you got 2 hydrogens. How are you going to arrange these? Well, we say whatever makes the most bonds goes in the middle. Nitrogen has 5 valence electrons and will make 3 more bonds. Hydrogen only has 1 valence electron, but only needs 2. So we're going to put the nitrogens in the middle. Okay, so nitrogen has 5 valence electrons. I'm going to go 1, 2, 3, 4, 5. And then I'll do the same, 1, 2, 3, 4, 5. Awesome. Well, I mean, if you want to, we have to somehow link these up, right? I mean, they're going to bond. So maybe let's just connect the dots. We'll at least bond them once. Now we have 2 hydrogen. Okay, so where am I going to put those 2 hydrogen? Well, they can line up by one of the single dots on the nitrogen. And now we try to make molecules symmetrical if possible. So I'm not going to put like 2 of the hydrogen all on the same nitrogen. We'd like to be fair to each nitrogen. And molecules do become more stable when they're symmetrical. So let's just give 1 hydrogen to each nitrogen. 1 valence electron. Hydrogen can only single bond. So there he goes. Oh, and now I kind of see what's left. Each nitrogen still has 1 more single electron. So we can double bond. Oh, okay. And I think I'm done now. The nitrogen are each full with an octet. Each nitrogen has 2 non-bonding electrons, or 1 lone pair. And then there's 2, 4, 6 bonding electrons. So each nitrogen has a double bond, a single bond, and a lone pair. And that's how he gets his total of 8. And the hydrogens are full. Now, what would not have worked is if I went like nitrogen, hydrogen, nitrogen, hydrogen. We say, yeah, these things are symmetrical. Well, watch what would happen here. If I put my dots around each atom, okay, so hydrogen's got 1 valence electron, and that's cool. Then nitrogen would have 5, and hydrogen would have 1. I don't know, something like that. Well, I could link up the hydrogen and the nitrogen, but then how could I link that hydrogen in the middle? You can't put a hydrogen in the middle of a molecule. You can only make 1 bond. So hydrogen, and same thing with halogens. They'll always be toward the outside. And it's the atoms that can make the most bonds. They're going to go in the middle and kind of form the backbone of the molecule. One more example. Let's try another one that's kind of similar. What if you add something like C2F2? Kind of looks similar, huh? What if I have C2F2? All right, well, the carbons are going in the middle because fluorine can only make 1 bond. It's a halogen. 1, 2, 3, 4. 1, 2, 3, 4. That's why obviously if you want to, you can connect the dots. They have to bond at some point. Then I've got 2 fluorine, and we try to make it symmetrical and be fair to each carbon. I'll go 1, 2, 3, 4, 5, 6, 7. And 1. I'm going to put the singles so they line up. 2, 3, 4, 5, 6, 7. Connect the dots. And now do you see what's going to happen to those central carbon? We can triple bond once, twice, and third in the middle. Oh, and I got a link on this guy too, don't I? There we go. Yes, I knew I had to connect them, but if it's not obvious, if it's a single bond, double bond, triple bond, wait till the end and see what you got left for any extra lone dots that were not paired yet. So here's a case where I've got my carbon in the middle, there's a triple bond between the 2 carbons, and a single bond to the halogen.